something that has changed is that Linux 32-bit is now actually obsolete, which is not what I said 5 years ago, but it has changed. More importantly, what does this mean? How obsolete is it? What is obsolete? What can be removed? What do we need to keep, and why and how? When I looked at what we have in the kernel, I did a huge inventory, and that will be most of my talk. I split this up into split this up into 5 different classes of CPUs. This is not working for me, I'm sorry. Help. So this is not my talk. Can you just mirror again? It's not going to work. I'm sorry, this is not my laptop. This is So these are the 5 classes of machines that we support. As I group them, and we're going to look at these 5 sets separately. The first one is going to be the traditional desktop Linux, because that's how most of us started using Linux, like a desktop or some kind of server machine. And we support actually still a great number of 32-bit desktop class machines in the kernel. Most importantly, of course, the x86 laptops that almost everybody had in the past before we all moved on to 64-bit ARM. And there's an overview that we'll see in a few seconds, where I showed every single platform that we have in the kernel. So these are all the major platforms and the milestones that we had. So we have, on the top, we have PC platforms, and then the color coding is important. So the green bits is where everything moved to 64-bit. We have the RISC platforms on the bottom. We have the classic CISC, x86, and S390 on the top. The red and yellow bits are 32-bit. Red means we no longer support it. Yellow means we still support it. And this is when it was the latest technology on the market. So the timeline here from 1984 to 2026, roughly when things got sold. And what's really interesting is we've had 23 years of 64-bit x86 now, which is much longer already than we've had 32-bit x86 for. Even though x86 was lived much longer than any of the RISC platforms, where we only had really a couple of years of 32-bit before things all moved to 64-bit in the mid-90s. So we had like 64-bit MIPS in 92, and then shortly after that we had Alpha and PA RISC and Sun. Everybody moved to 64-bit. x86 was late, and ARM was the one outlier that moved a lot later. So 64-bit ARM only started like 10 years ago, as most of us remember. So that means on the classic desktop market, everything we see here is pretty much a museum piece at this point. Nobody's using them for serious work anymore. You can still use a laptop from like 2006, but even the ones from 2005 are too old, and the ones from 2007 are going to be 64-bit. So that's a very narrow range. And then the outlier, of course, is things like Chromebooks that we had a few years ago. There were still 32-bit Chromebooks, and of course Android phones, which you can classify as kind of general purpose compute stuff. They're somewhere in between classic embedded and things where you can install your own applications, like on a desktop. So depending on how you classify Android phones, we might still have this use case here. This is, again, not working. Okay, so looking at everything that's not desktop, so the entire embedded market, and just in this release, so 6.16 is the first time where, just counting the number of device tree files, 64-bit ARM has surpassed ARMv7. So we have ARMv7 on the right side here. There's ARMv7, there's ARMv8 and ARMv9, and this is anything older than ARMv7. And these are all the other architectures. So 32-bit ARM, roughly half of the embedded world. 64-bit ARM is as much as the ARMv7. And everything older than that is already in the noise. We have a couple of licensable architectures. So these are special because we don't actually know who's using them. We don't have any boards that we support, but anybody could get one of these either for free or license them for money, build their own CPUs, build their own systems. And all of these have moved to not to 64-bit ARM, but they have moved to 64-bit RISC-V. And for pretty much each of them has one maintainer who really cares about these platforms. So that's why we still keep them. And there are users that we know are out there, and eventually they will go away. Yep. So RISC-V32 is interesting because it's fairly modern, but we don't support a single machine. So all the RISC-V stuff that we support in the kernel, where we have a device tree file or we know that there's a platform that exists, those are 64-bit. We know that some people are using RISC-V32 for some experiments, but they are not using a mainline kernel. I don't expect you to read all of this. So these are the 30 most common embedded platforms that predate ARMv7. And we can see on those how long things take to become completely obsolete. So again, what you can see here, the colored timeline means how long a chip has been available for sale. So a lot of the chips that we support in the kernel, and I didn't include any that we have removed. In the early 2000s, they got introduced on the market, and a lot of them have disappeared from the market. So these have ended, these have ended, these have ended. But we still support them in the kernel. So they got sold for between 10 and 20 years. And even though they have been discontinued, we still support them because they are existing users that we need to support. And I last asked around every one of those platform maintainers, can we remove them? That was 5 years ago. We removed quite a bunch. These are the ones that were still needed 5 years ago. And we can probably remove a couple more. But most of these would still remain because we know that people are using them. There are 3 platforms on this list where the manufacturers still make new chips, and they have not moved on to 64-bit or to ARMv7. The ones are the microchip, formerly ATU91 series. Now the latest model is the SAM9. Then we have the Vortex 86, which is an x86 chip, and we have the Ingenic MIPS Ingenic here. So these all make super low-end chips, usually single core, not ARMv7 yet. Might get turned into 64-bit RISC-V or 64-bit ARM at some point. But at the moment, there are still new chips coming out. A lot of the platforms still have new boards coming out. There are, I think, 6 or 7 where you can still buy the chips. So if you can't buy the chips, there are probably no boards coming out. But you might still have people adding support in the kernel for old boards that are being used but not sold. Yes.
The Super H, so is it going to continue?
Sorry.
What is the story about the Super H?
Super H. So Super H, as you can see, so these are in 2012. Oh yes. So the darker colors mean the ARMv5 or PowerPC or MIPS was the latest one that was available. So in 2011 on the Super H, that was where they introduced the first ARM Cortex A9 based chips that replaced the Super H. But the end of life date for the Super H based chips is in 2025. So you can still buy those chips and they guarantee availability. Next year, they will not guarantee availability of those chips anymore. So this is a 25-year lifetime for these chips. We could buy them. They're still supported in the kernel. Almost nobody's using them. So yeah, I should have made that clearer. So all the yellow bits, those are ARMv7 and ARMv8 chips, and in some cases ARMv9. So for example, on the IMX line, you can see an ARMv4, V5, yes, V5, V6, V7, 7, V8, and V9 chip in one product line. But they're still selling the old ARMv5 chips, if you know where to look. So that gives an impression of how long we have to support stuff that is objectively completely obsolete and has been for 10 years or longer. This chart just shows baud files getting added for ARMv7 over time. Sorry, not baud files, but device tree files. Initially, we were replacing traditional baud files with device tree files, so you see a huge number of machines getting added around 2013, 2014, and from then on, it has only gone down as we started adding 64-bit machines. But as I said, the total number of ARMv7 machines only just got surpassed by 64-bit ARM. And you can see the colors. So we have the blue Cortex A8, the yellow Cortex A9, green Cortex A7, and then everything else in red. And Cortex A8, we can see, again, this has been pretty much obsolete since 2016, where we stopped adding a lot of boards. But we're still adding a few boards. So there's a really long tail, even for an old technology with a single-core chip. We also see this largest area, that's all the NXP IMX6 chip with the Cortex A9, which we started seeing in 2012. And it's still one of the most popular chips overall, even though most of the other Cortex A9 chips have gone away. Most of the rest of 32-bit is all Cortex A7. This one chip still stays around. So overall, most of the SoCs we support use Cortex A9s, because that was a super popular core. But most of the new stuff that we still see get added nowadays is Cortex A7 based, because that is the most modern 32-bit core. Yes, and we can expect this to keep going for another 10 years before we stop adding boards completely. I do not expect to see a lot of chips getting added, but as we've seen with the one ARMv5 SoC that keeps getting new revision, there will be a couple of those. So probably for another 5 to 10 years, new SoCs will get added, or old SoCs that people only now start contributing upstream because of whatever business reasons or hobbyist reasons. And so each board that gets added now, there's a good chance that we will be using this board and updating kernels for the next 10 years after it's getting added.
Do you recommend the vendors to move on to 32-bit, or do you still accept for 32-bit ports to be added?
So we obviously accept anything that, like if the quality is fine, we don't stop accepting the boards, and we keep supporting them as long as they are needed. And there are good reasons for updating kernels on old boards. It's a little bit different for the microcontrollers, so things that don't have an MMU. So this is a special class of chip. In Linaro, we were still working on these in 2017, but that has pretty much stopped. So 2017 was where a lot of companies like Linaro, we all moved on to other real-time operating systems as soon as things like Zephyr became available, where you have something that was just as open source as Linux, but better tuned for the things that use these chips. So development on MMU-less microcontrollers has pretty much stalled for the last 8 years, and I would hope that we can remove those in a couple of years as things progress further. So pretty much everything in there is either supporting old customers that had these a decade ago already, or this is just hobbyists where somebody tries to get things working for fun, to prove that it's possible to still run Linux on a tiny microcontroller. And that's great fun. But when you talk to the memory management maintainers in the Linux kernel, this is really annoying, having to support the no MMU code base when there's almost no users that use this for anything productive. So there's a lot of pressure on having these removed at some point in the future. And my hope would be that in 2 years' time, maybe we can remove the ARM Cortex-M support, just as these are becoming less and less common. And even the vendors that are still supporting their customers today stop doing so. There are a few other pain points for 32-bit in general. The big problem that is, again, causing problems for memory management maintainers is highmem support, and that impacts lots of parts in the kernel. So device drivers, file systems, memory management, they all have to constantly worry about what happens if a page pointer is backed by highmem and you can't actually access it from the kernel. So we have a lot of code that's only used on machines that are 32-bit, but have more than 1 or 2 gigabytes of RAM, and these are exceedingly rare. So very few users and a lot of work to maintain this. And I'll talk a bit more in depth about what we can do to reduce the pain that this causes. Sparse mem is another one of those that some people are asking about getting rid of. We have a problem as we worked on, like I particularly worked on the 2038 support in the kernel, moving everything to 64-bit time T, but in user space things are lagging behind. And then distro support is becoming problematic increasingly as packages, like upstream maintainers of user space packages, care less and less about 32-bit mode, and they introduce bugs and things just randomly stop working on 32-bit because users stop caring. And like rewriting stuff in Rust means that there's new code being